In this video, I will calculate the unknown charge of the particle based on data collected for distance and electric field strength shown here to the left. The independent variable is distance, the dependent variable is electric field strength, as distance would be the measurable quantity that you could control yourself. So to solve for this graphically, I need to insert a graph, but before I do that, I need to recognize that my distance measurement is not in standard units, so I will actually create a new calculated column for distance away in meters rather than centimeters. And I will format my first cell here so that it calculates 2 meters for me by taking my previous box and dividing by 100, and I can actually click and drag this blue box in the bottom right corner to copy that format for all of the data points, and then I can copy my Y variable, my electric field, over so that when I insert my graph, it will actually graph X versus Y rather than flipping it around. So I can select my data and insert a chart. And I quickly realized that from the data collected that there's a strong trend, and the numbers are pretty large, so it's hard to see here, but we're at 125 million newtons per coulomb with this very small distance, and then as we get about 14 meters away, our strength is reduced to 89 newtons per coulomb. So we kind of have this decay trend. So that tells me that I'm not going to be able to get anything linear from this graph. And if I look at my cheat sheet on how to linearize data, the trend that I'm seeing here tells me that I should graph my Y versus 1 over X rather than graphing just these general data points. So I need to now create a column that will graph 1 over X, or 1 over my distance. And so I'm going to again create a formula in my first box that will calculate it for me to eliminate any math that I would have to do myself. So just 1 divided by the box that I'm clicking in for the previous graph. And then I hit enter again, it calculates for me. I can again drag down and copy the formatting over. And then once again, I'm going to copy my Y column. And then I can try to insert my graph here. So now when I insert a graph, I'm still noticing that I don't have a quite linear trend. It looks a little bit more exponential this time. So if I'm seeing an exponential, I will also need to square the X according to my cheat sheet, how to linearize sheet. In order to do that, I will now graph 1 over X, 1 over X squared, meaning 1 over distance squared. And now I will just do 1 divided by my previous column for distance squared, and drag this down. Copy my Y column again because those data points are still staying the same. And now I will graph those 2 columns to hopefully get a linear slope or linear trend. Pick my scatter plot, and it looks pretty linear this time, so I can go to my customization. This is actually electric field versus 1 over distance. You got to be careful. Sometimes Google Sheets will mess up your axes. The horizontal axis is actually 1 over distance squared. the vertical axis is actually electric field. And I can get my trend line that now goes through the data points. And it pops up with a few more options. I will select the use equation option and I get a slope of 18,002.6. Okay, so there's my chart. So if my slope is 18,002.6, I then have to use some unit analysis to figure that that's not actually my charge, because my units don't come out to coulombs. It comes out to coulombs with some other components of force and mass. So what we do is we look up and find that there's actually a constant that's included in this relationship that we have actually already learned about. That constant in this case is 9 times 10 to the 9th. So if we just want to isolate charge from the slope, we would assume that this is equal to the constant combined with the charge. And so we would divide our slope by the constant, and we get, just like we did in the last video, 2 microcoulombs. Coulombs.